it is about student. If it is false, it is about faculty. We solve the problem with a condition. If it is student, I do whatever I like to do with student interface or whatever access you want to have. If it is else, it means it is about faculty. But we are not dealing only with students here. We are dealing with students who are graduated, who are part-time, who are transfer. There are many status only for students who are withheld. So I can do that one. I can put another if graduate and full-time, because there are PhD students, they can be full-time or part-time. So if they are satisfying this condition, do something. If not, it means if it is not graduate, do something else. So you can imagine what it is going. There will be tons of if else here. We call this kind of code spaghetti code. Never ever do spaghetti code. Do not use too many if else. It is not AI. So it is bad. So what is the solution? I can have two different classes, for student, for faculty. What might be the problem here? The problem, I am going to write a method here, and same method will be here. But let's say you are dealing with students, one of your colleagues is dealing with student class, another one is dealing with faculty. At the end, there should be a relation between these two. But how I am handling the methods class, it is my way. I have my own way, and I like to deal with different methods than my friends. So there will not be consistency between the methods, between the data fields. And then it will be a disaster. Where might this go wrong? Consistency, storing all objects in one data structure. This is important. Here I am using array, there he's using array list. First name, last name, I am using first name, last name separated. Here he's using just name, first name, last name together, just name. You see, there might be a lot of problems. It is not the solution. No column way, single array for everyone. Here I am using single array, maybe. Because if I use like a student and faculty separated, I am going to create one for students, one for faculty. It might be better. Why? Because sometimes I am going to search for a specific faculty. If I keep all of them in one, I have to check, let's say, 5,000 records to find out where is that faculty. In faculty, I have only 100 faculty. Why do I need to search 1,500 or 10,000 records? What do you want then? Keep common behavior in one class. Split different behavior into separate classes. So I'm going to have a general class. Under that class, I'm going to have separate classes who has different behavior. Keep all of the objects in a single data structure. So we are talking about superclass and subclass, inheritance, class hierarchies. I am going to have a person class. It has the common things. Both of them has student and faculty. Then I have separated classes. I am going to just inherit whatever I need in person class and use them. Same thing is here. Name is common, so I don't need to put name here again. ID, they are going to have ID. So I have all the common things in the super class. Then do I have something specific for students? So I keep them in the student. I have something specific for faculty. I keep them here. But there will be a relation between these three classes. How can I connect? Let's say I have some methods here. So I can use the same method here. I just inherit it. I will say that, okay, I obey you person. Let me use your methods. So I will directly take the methods and use it. I don't need to write it again. How am I going to do that one? Just extend person. So this is my superclass person, and this is my subclass. When I say extends person, I am going to inherit everything from person. Plus, I might have some specific things. They don't need to be in person. This extends. So this is base superclass, and this is derived subclass. What is inherited? Public instance variables. Data fields, name, these are. Public methods, they are inherited. Private instance variables. Private variables can be accessed only through public methods. So you remember getter and setters? That is the reason we were writing getter and setters. So I cannot inherit them. I have to use these methods to get them. There will be too much detail there. Let's carry on. So this is how we are going to show in UML. That arrow shows that students inherit from person superclass. Person class, it has one method, public get name, return name, and this is my student class. Why get name? Because this is private. I cannot reach that private data. I have to use this public get name method to reach that data. Inheritance hierarchy, you can have many subclasses, but you cannot have more than one superclass. I cannot have more than one superclass. Student can only inherit from one class. In Python, it is okay. You can inherit with many. If you like to inherit from many classes, we are going to use interfaces. That's going to come after midterm. What belongs in student class, but not in faculty class? Like GPA. I don't need GPA in faculty. So double get GPA. This is a method. I don't need that one here too. Same thing for faculty. I have salary. There is no salary there. Double get salary. This is the method. I need them. But the rest, name, common. Both of them are using name here. So the common code, divergent code. This is our person class. We start writing private int ID. These are private, since this is negative. Private string, private department. I have a constructor. It has name, ID, and department. ID, name, department. Very nice. And methods. Get ID, return ID. Here, why do I use this ID? Why didn't I use this ID here? This is a question from last week. Because I'm using that ID. If it is IDX, you don't need to use this. You just say ID is equal IDX, that will be enough. If you use ID, same name with the global one. This is the local variable. This is the global variable. If you are using, if you insist to use same name, then you have to tell compiler that this is the global one. This is the local one. Here I didn't use because I don't need. It knows that directly it is putting this here implicitly. Here I have to put this one explicitly. Compiler will confuse otherwise. Why? Because I am using this variable locally in that method. So these are the methods. Okay, perfect. Now what about subclass? How am I going to write it? Am I going to enter all of them here? You see, I have only GPA here. I don't have ID, name, department. I have a constructor. It has ID. Where is ID here? There is no such a thing. ID is here. Name, I don't have name here. Name is here again. And department is same. Except GPA. I don't have GPA. I edit GPA here. So this ID, name, and department will come from superclass. I don't need to write them. So superclass has a power to play with them. If it changes, it's going to change for all of them. There are many methods here. I can use them all. They are all public. They are all mine as a student. Plus, I need two more. Get GPA, set GPA. How am I going to write that one in Java? So we extend person. Private double GPA. I don't care ID and name department. They are coming from person, which are here already. ID, name, and department. My constructor, I have ID, name, department, which are not here, but they are coming from superclass. I have only GPA. So how am I gonna initialize them in the constructor? I like to initialize them. I have to initialize them. I just say super ID, name, department. I told that go to my superclass. That is why I am inheriting. Take them from there. Take all the features about them. ID, it is integer, so it will know that it is integer. I am supposed to enter integer. It's going to be referred as ID. So ID, name, department comes from super, except GPA. GPA is mine. I edit that one. This.gpa here. Get GPA, set GPA, they are normal public methods. Nothing special. Only the difference is here. So I inherited those fields from superclass. Is a relation between classes. Superclass, I am creating this one, person P, new person. Is it possible such a thing? Yes, till now we have done it worked, so it means it is okay. We are asking this question. A person is a person. Yes. What about student, new student? If I run that one, student as new student, this is gonna work. We knew that one, we have already done it, worked. So we know that a student is a student. It is referring student, which is in the student class. What about this cross? Person, P, new student. Do you think Java should let you have a person reference point to a student object? So this person reference point, it is going to point a student object. Is such a thing possible? I am trying to join my laptop. I cannot see the answers. You can open your microphone and tell me. Or your silence means you know the answer. You are just too shy. And my laptop is not turning on. So I will carry on. This is superclass, this is subclass. Such a thing is possible. Because a student is a person at the same time. Is a person student. So I can do like this. Person, create an array, P, new person 3. So there are 3 objects here. I can say that P0, new person. P1 will be new student. P2 will be new faculty. This is polymorphism, by the way. A person array can store student and faculty objects. So you can use such thing. It is very useful. I'm going to have an array. Everybody is there. All the features will be there. And I have all the objects. They are gonna be kind of objects there. So this is possible. What about this one? Student's person. Can you have a student reference point to a person object? So one of them should be wrong. You can guess that this is wrong. Not every persons are students. They might be faculty too. So we cannot do such thing. That's going to be wrong one. Is it okay? Person is a superclass. Under superclass, you might have students or faculty. It's going to be accepted. Person P, new student. Person P, new person. They are okay. But students, it is subclass. Not everybody is student in the person. So it is not accepted. It is wrong. That is supposed to be superclass. That is supposed to be subclass. Okay, I have 2 classes, person, superclass, student extends from person, faculty extends from person. I am going to run them all one by one. Which of the following lines of code, when executed in sequence, will cause an error? Let's run them one by one. String n s.getName. I have created this one. Student S, new student. Person P, new person. Person Q, new person. Faculty F, new faculty. Object O, new faculty. Object is the super class. Okay. So I have here extends object normally. I will come to that one. So all the classes, if you don't explicitly say, they are all going to inherit from object. Object is the super class. So if I run this one, string n s.getName, s new student, we came here. s.getName, new student s. What am I going to have here? The name is there, it is public. So first it's going to check, is there such a method here? No, then it will check the superclass. Is there such a method here? Yes. Then it is going to return. This is okay. P is equal S. What is P? Person. S is student. That is again possible because student is a subclass and every student are person at the same time. What about m is equal to p.getID? What is m? What is p? Person. Get ID in person. Is there such a thing here? p.getID. There is no such a thing, so we are going to get error. Person, I have only one method, getName. It doesn't have getID. GetID, my subclasses, they have this one, but I cannot inherit from them these methods. To inherit them, we are going to use casting. You remember the casting for integer, float, string? We are going to do the same thing here. We are going to cast student p.getID. It is going to run this method. If you want to cast with faculty, write here faculty p.getID. So you're going to get faculty ID. Faculty is equal to Q. Now every student's person. Every person are faculty? No. What about this one? O is equal to S. O is the super class, S just a student. So every students are objects, yes. Why it doesn't accept my login? Visibility modifiers, we have seen a little bit. Now we have to talk about when we have super subclass, how they are going to work. Public and private. If it is public, less restrictive. If it is private, more restrictive. And we have middle, some other status. Can access from any class, can access from same class. Make member variables private and methods either public or private. We have another one, protected. Can access from same class, can access from same package, can access from any subclass. Default, if you do not specify the status, public, protected, or private, it means it is default. Can access from the same class, can access from the same package. The rest, no. Lose access by any subclass. For example, I have this one, sample class. I have one variable public, another one is protected, default, and private. These are in the same package. Subclass, superclass. It is only in the same package, that's all. It has nothing to do with any of them, the other two. Public omega. Public omega, they all can reach. If it is yellow, it means they can access them. Protected, only the package and subclasses, they can access them. Generally, this is bad idea because it doesn't. You don't rule this one. They are in the same package, and you let this guy to touch your protected things. It is not a good idea. You better use as a subclass or don't do such a thing. Why? It is default. If it is default, you only if they are in the same package, they can reach. Otherwise, even if you are subclass, you cannot. Private is private. Nobody can see, touch. It is only for superclass. Object creation in Java. All classes inherit from the object class. As I told you, object is a super class. All the classes inherit from object class, but we don't see. It is implicitly written by the compiler immediately when you run. Java object construction occurs from the inside out. What does it mean? Person, some of your friends are walking around here. Person, superclass, student, faculty. Now new allocate space for the constructor, student constructor. This is our reference. This is passed to the constructor. Objects are created from inside out. It means this is the student. Now person, it will go to person, then it will go to object. Student inherit from person, person inherit from objects. Superclass indirect, this is superclass, subclass. So this is the object, the superclass. This is the person we are inheriting, and this is the student. It goes from inside to outside. This process we have essentially initialized. All these variables went all the way up to object and all the way back down. That is what we mean by initializing inside out. First, we are going to check object, then person, then student. When you create this object constructor, it is going to check person. Person is check object. Compiler rules. How Java compilers ensures object construction occurs from inside out. This is our code. Java compiler process code and inserts new commands. It is doing that one implicitly. Then it goes to bytecode, runs on Java virtual machine. So you just write simply your code, but after that many things happening here. Java doesn't trust you at all. It is putting implicitly many extra codes to your code, completing it. After that, it sends to bytecode, convert to bytecode, then runs on Java virtual machine. So this is my class. How will the compiler change this code? I write this and I run. When you run, there are 3 rules. Rule number 1, no superclass, compiler inserts immediately, extends object. So compiler is inserting this one. Extends object. Rule number 2, no constructor. I don't have constructor here for person. Java gives you one for you. No argument constructor. If you don't have constructor, Java is going to put this constructor for you. No argument constructor, be careful. I'm going to mess with your mind with this one later. Rule number 3, the first line must be these arguments, the constructor, or super arguments, super constructor. Otherwise, Java inserts super inherited constructor. Same class constructor call, super class constructor call. If you don't have them, if you don't have any of them, Java is going to insert this one, super, no constructor argument. So edit by compiler, class person, this is what I write, this is what happens. Extends object, public person, because I don't have constructor, Java put this no argument constructor here. Let's have here now these 3 rules, let's see them. I have student extends person class. Extends person has superclass, so first rule doesn't apply. What was the first rule? If I didn't have any superclass, it was going to add here object, extends object, but I have already, so it doesn't apply here. Second rule, I don't have constructor, so second rule does apply. Immediately Java put here no argument constructor. Third rule, again it applies because I didn't need to call super's default constructor. I have this default, this constructor, no argument constructor. In that one, it is going to call superclass no argument constructor. Okay? This part is very important. I fail many students in midterm, final from here. Extra attention here. Rule number 3. First line must be same class constructor, superclass constructor, or Java is going to put no argument super constructor. Why do we need to know them? They are important when you debug the code. 3 rules, easy. If you know them, it will be easier for you to debug them. Person extends object. Private string name, this is my constructor, super. I can start a constructor like that. This is my person class. I have one private data field. This constructor, it asks one arguments. This dot name equal and then super. Here you don't need to put this one. It is coming automatically. If you insist to put by yourself, this is wrong. You have to put this one first, before everything. Super has to be the first line. Okay? Like this, it is going to work like that. Now I am going to extend person and create a subclass student. Public student, no argument constructor, initialize name variable in student. What happens now? I have no argument super constructor. I came here. There is no such a thing here. There is only one constructor. It has an argument. Then I say this dot name is equal n. I have one argument constructor here. How to initialize name without a public setter? This super is not going to work because there is no argument constructor in superclass. Okay? By putting this one, you are looking your superclass. If there is any with no argument constructor, there isn't. There is only one constructor. It has an argument here. So this is gonna wrong, and you don't need to do this one. You are going to initialize with super parenthesis n. What is n? The string, the name. Okay? So this is how you are going to initialize. Let's add no argument constructor. This is another way. You enter directly the string here. Remember, I said this dot n is equal n. You don't need to do that one. You just put here super student. Is it gonna work? This argument, it doesn't have an argument, be careful, but it is extended from person. In person, I have this argument constructor, so this is going to work. It will check. There is a constructor. It is looking for a string. I have a string. So it is going to work immediately, and it's going to replace name, student name with student here. You can use super student or this student. Use our same class constructor. Both of them are referring same thing. Let's say I am creating an object of C class, C1. I have a class A, B extends A, and C extends B. So this is superclass. B extends from A, this is subclass, and C extends from B, this is subclass of B. When you create a constructor, it is going to check, super constructor is going to check this one, if there is such a constructor here or not. When you create an object, this one is going to go and check A here. This is called constructor chaining. Here I have superclass, B extends A and C extends B. When I run this one, C1 new C, what happens now? It comes here, C. It doesn't check constructor immediately, it checks extended. Is there a superclass? Yes, let's go there. It comes here, B. It checks, does it have a superclass? Yes, then go there. Be careful, I didn't run anything here, I didn't go inside the constructor yet. I am just checking, I call this constructor, I try to initialize C1. I check first thing if it is inheriting from a superclass. If it is inheriting, it will jump to that superclass. So I came here, it is inheriting from A, I will jump here again, and I check this constructor. So I checked, okay, it's a no argument constructor, it is gonna run this statement. It is done, it will come back, now go inside, run this statement. Now I am ready to run the statements here. Whatever I have, it's going to run this one at the end. This one line code causes you to visit all the superclass constructors. Okay? I hope it is not that messy, but I try to make it as clear as possible. I check many books, YouTube videos, other professors, and this is what I came up with then. Checkpoint. Try once more. Have a look at the question, guys. Take your time. What is the student's wireless password? Epocoini, yeah. What is the order statements printed? I am just creating a new object of students. Now let's have a look. I have a person. It is a private string name. Then it's a one argument constructor, string n, this name, and then print out this one. At last. I have student extends person, nice. Public student, it's a no argument constructor. It starts with this, okay, then print number 2. Then I have another constructor of student with one argument, super n. Super n means this is the super, it's gonna go there. But this means it is going to check the same class constructor with one argument. Do I have such a thing? Yes, I have such a thing. It is looking the same class. Super means it is looking to super class here. When I run that thing, it is no argument constructor. It will come here. No argument constructor. If I have this one, it is going to check this constructor first inside. So it will come here. Let's go line by line. So we are here first. Whenever you start, it knows that you have a super class, then it checks the first statement. Do I have super n or this student? So I am referring another constructor in the same class, so I will go there now. It came here because I have such a constructor with one argument. Now it checks here, do I have super constructor? Yes, I have. Explicitly, I have written that one. If I didn't write that one, it was going to be implicitly super no argument constructor, and it was going to go there and check no argument constructor. Here, explicitly, I say that go to superclass and check with one argument constructor. It is going to do that one. Come here. Yes, there is such a thing. It just give this name N and print out number 1. Where am I now? I am still here. I'm going to finish this one. I am going to print out this one. Then I am done. I will come back and print out number 2. Is it messy enough to ask you in the midterm? It is overprotected pattern, parent, yeah. Do you have any questions, guys, about this question, this one? At last I opened the other one, my chat is open. For the shy ones, yes, for the shy one you can use here. Will these topics in quiz and midterm? Yes, I should ask in the quiz for your good. I don't want to ask because I am just giving all my questions to you. It is not good. I will be short of questions for the midterm. But it's okay for me. I can try to find more questions, generate more questions. But this is the question I ask, for example. What is the output? You have to follow very well. You have to clear your mind and be careful. Just remember those 3 rules. If you don't specify super or this, super no argument will come automatically. And you always go and check your superclass constructor first. You follow this hierarchy. Another checkpoint. Student as new students. We create it now. What happens when you call student no argument constructor? I called here. When I create this object, I am calling student no argument constructor. So I have a person. Let's check the student. Yeah, there is a student. Extends person. It is inheriting from superclass. I came here. It has a no argument constructor. Inside, do I have this super constructor? No. Do I have this constructor? No. So what will happen? Compiler is going to put here super no argument constructor. It is referencing the super. So I will come here. Do I have a person constructor without argument? No. Then it is going to give me error. Compiler. Okay? Do you understand this one, guys? Whenever you create this one, no arguments, this is initializing, it will come and check. Okay, I have a no argument constructor, but there is a problem. I am extending the person superclass. Now, do I have here super constructor? No. So it is going to create for you super no argument constructor, and it will run it. It runs, it comes here and checks. Do I have no argument super constructor? No. Then you are going to get compiler. I hope you are okay with this superclass, subclass. Now I like to talk about overriding and overloading. Overloading, same class has same method name with different parameters. In the same class, you have same method name with different parameters. It is overloading. Overriding, subclass has same method name with the same parameters as a superclass. The parameters are same. You have used integer in superclass. It is integer again. The methods are same name. Only you are doing something else in the method. But overloading, you in the same class have the same method name with different parameters. Here, for example, I have test method here, main method, B superclass, A extends from that one, A subclass. I have a P method, it gets a double I and it multiplies by 2. I have same method, P double I, but here it just print out I. It doesn't do the same thing with the superclass. So this method overrides the method in B. It has the same parameter, same name, only the operations are different. This is overriding. Overriding super method. So what am I going to see if I run this one? A.p10. I created this one A new A. When I call p10, it is calling this method. First thing, your compiler is going to check out if I have this method in my subclass. If I have, it is going to run that one. Argument is okay. It is double integer. It doesn't have integer there. It's going to print out 10. When I call again p10.0, doesn't matter. It's going to come out and print out this one again, 10. What about here? I have p double I and p integer I this time. Same method. Method name is p. In superclass, I have p method. It is multiplying by 2. In subclass, I have the same method. It doesn't do the same thing. It is just printing out. And the data types are different. This is double. This is integer. Now I created an object of A class, and I run the p method, A.p10. A.p10, it checks. I have p method in my subclass. The argument is integer. It is going to run and print out 10. I run again this one, same method, this time double. They are same, double. Now it is checking, okay, I have p method in my original class, subclass. But the argument is integer here, that one is double. Now it is going to check the superclass. Do I have same method with the exactly same data type? Yes. Then it is going to run superclass p method. This is called overloading. First one is going to run my original class, other one is going to run superclass, multiply by 20. Okay? Special for string method we are using to string method. Override string method defined in the superclass super dot to strings. For example, you want to explicitly run the method from superclass, you just put here super dot whatever the method is. If you don't want to leave anything to the chance, just specify explicitly super dot to string. It is going to run the method from superclass. Yeah, the instance method can be overridden only if it is accessible, if it is public, or if it is in the same. If it is protected and if it is in the same the package. If it is private method, it cannot be overridden. Identify the problems in the following code. I asked this question again in quiz and midterm. I am too generous to show you all of them, but it's okay. What are the problems? Go line by line. Circle, double radius, radius equal radius. Yes, guys, problems. Hurry up. This one is radius, that one is radius. Yes. This radius is the global one, this radius is the local one. And you insist to use the same name. If you insist to use the same name, you have to specify this radius. This radius we are talking about, the global one. So this is first. There are two classes. First mistake. Second one, This one is okay. I don't need to specify because it is directly putting this here and it's okay. Same thing, this one is fine. Double radius, double length. Double radius I have, double length is coming from there, very nice. Then I say circle radius. What is this? Circle is my superclass. Have I ever done such a thing here? This circle, we don't show like that, we show with super. Okay, the syntax is super. Don't write a superclass name here. When you say super, it refers to superclass because you have only one superclass. Super radius, so you initialize the radius. Length, again, same thing. You have to use, if you insist to use this name, you have to specify this dot length. Now we are overriding here, get area. I have get area. Return get area times length. What get area is this? And is this kind of recursion here, or what get area I am talking about? Most probably I'm talking about this get area. I am getting this area and multiplying by length. So I am referring this one. So how am I going to refer superclass method inside here? I have to say super.getArea. Specify that I am referring this one. So I'm going to do these calculations, multiply by length. These are the errors. Last slide, final modifier. Final class cannot be extended. Final class method. The final variable is a constant. We mentioned about this one. You know, pi is a very long number, but you want to fix the number so everybody will have the same results in your group. So you can fix it so everybody will have this pi. Cannot be overridden by its subclasses. Congratulations, we finish inheritance. I like to start polymorphism, but I need a break. I believe you need a break too.